Have you ever wondered whether these could be turned into this? Well, that would be a good question to ask as the energy crisis abounds, affecting everybody around the globe, and it has been asked. Increasingly, scientists, economists, and governments are developing new alternative energy sources to fuel our everyday lives. Alternatives such as biofuels. If you think about it, biofuels are not too radical of an idea. Biofuels were the earliest energy source known to man. Ever since prehistoric times, people have been using wood, a source of biofuel, to light fires and cook, keep themselves warm, and provide light. Now, more and more scientists have begun researching the possibilities inherent in the development of biofuels in order to incorporate them in our lives in place of fossil fuels.
About 5 years ago, the federal government came out with a mandate about how much of these advanced biofuels needed to be made. So one of those mandates is an increase in something called cellulosic biofuels, and those are often called second-generation biofuels. That means production of biofuels from plant sources, and it usually means, if not implies, non-food plant sources.
The biofuel industry has advanced and expanded immensely. Organic matter is now converted into liquid fuels in biofuel processing plants and can be used in a variety of different ways. In the following presentation, we will share with you research and recent developments in the biofuel industry in the United States and Brazil, with specific reference to scientific, social, and economic sectors, and ultimately global implications. We will use this information to discuss the benefits and drawbacks of transitioning from fossil fuels to biofuels as transportation fuel in our global society. We believe that in the future, current developments in the biofuel industry will allow a combination of alternatives to take the place of fossil fuels, depending on commodities available in various regions around the globe, and the most economical, efficient methods of incorporating alternative energy into our lives. While fossil fuel requires millions of years to form, making it a non-renewable resource, biofuels can be created as soon as the biomass is present. Since it is renewable, it presents itself as a possible solution to the growing energy crisis. Biofuels such as ethanol, biodiesel, and biogas are produced from plant biomass or municipal and industrial waste. Biodiesel is made from soybean, canola, and other vegetable oils, animal fats, or recycled grease. It can be blended with regular diesel fuel and can be used in most diesel engines. Some engines can also be modified to run on pure biodiesel. Biogas is another type of biofuel made from animal waste, sewage, or other decomposing waste materials, such as those in landfills. Biogas therefore contains methane, which is also the main ingredient in natural gas because it is released in the process of plant, animal, and waste decay. When burned, biogas produces heat which can then be converted to electricity. The lower carbon footprint of certain biofuels compared to those of coal and oil make biofuels attractive as an alternative energy source to some groups of people.
If you manage to get biofuels to be cost effective, that they are really competitive towards in comparison to oil, then you basically achieve this goal that consumers will choose the fuel that is most in their favor. So how can you do that? There are a number of policies. There are policies like subsidies, policies like research and development incentives to make in the medium to long term biofuels more cost effective by increasing the productivity and yield of biomass. So you have a bunch of policies to achieve that. However, you can only control part of that equation. There is one variable that you don't have much control, which is the price of oil. So if the price of oil goes down, as it did back in the mid-80s, for example, so Brazil had this huge program to support ethanol, but when the price of oil went down and the price of sugar, that is, that you can basically use sugarcane to produce ethanol or sugar, went up, producers started to produce more sugar than ethanol. So in the mid-80s, it was a partial failure of the Brazilian program. However, thankfully, in the 2000s, you had a new technological solution called the flex fuel technology of motor cars. So basically, the engines of cars in Brazil, they can run with any combination of ethanol and gasoline. So you decide at the pump if you are going to use ethanol or gasoline, depending on the price. So that is a very effective, market-friendly way of marketing renewable food.
Let's look at some new research centered around the use of microbial processes in biofuel production and the conversion of algae to another type of biofuel, butanol.
So the way these processes work is you have a microbe, and microbes are very efficient, at least some microbes, at taking what we call sugars. So you have to have processes that can take the feedstock and basically release these sugars so the cells can consume those. So you have to take the material, you have to grind it up into small particles. Then you have to treat it with things called enzymes. Okay, so these would be material or chemicals that break the biomass down into these sugars. Okay, and then that mixture that you get after you do that's called a hydrolysate, because the biomass has been hydrolyzed. And then you feed that to the cells, they grow on that and make the fuels.
Like microbial processes, natural microalgae processes can also be used to create butanol.
We're looking at algae as a feedstock to make fuel.
While corn used for ethanol places a demand on our food supply and requires significant amounts of land area, algae thrives conveniently in lakes and rivers, grows at high rates, and benefits the environment by removing carbon dioxide from the atmosphere as it naturally undergoes the process of photosynthesis to synthesize sugars.
But butanol is more stable.
You actually get a higher mileage because it's got a higher energy density when you use butanol than ethanol.
The butanol can also be solarly put into the engine, but the ethanol cannot.
Overall, a comparison of butanol to ethanol as a transportation fuel shows that we are headed toward an even more sustainable future for biofuels with research like Dr. Hestikins. There are two ways to convert energy in algae into energy for a car, aka to turn algae into fuel. One way is to use fatty acids. The second way is to use sugars, such as glucose. The process that uses the sugars is more efficient than the one that uses the oils because algae naturally produce glucose via photosynthesis. Using an acid and heat process, the cells can be broken up and sugars released. This sugar ferments in a process of fermentation led by bacteria and forms butanol, which is an alcohol. Although biofuels may sound like a great and easy alternative to fossil fuels, using biofuels puts societies at risk of a lower food supply and negative climate impacts.
ABC News to call attention to another crisis in America, hunger here at home.
The problem comes with land use, and I think that's where biofuels are problematic because you're taking land out of food production or grazing production or other use production or even wilderness, which is valuable for the production of biofuels.
The arguments people make is that biofuels are more CO2 neutral, right? Because the good thing about plants is they eat CO2, right? So if you grow a lot of plants in order to make fuels, in order for those to grow, they'll tend to consume lots of CO2. And so that'll tend to give you a more kind of neutral, CO2 neutral world, if you will. Because whatever CO2 you might be producing, for example, using these fuels would be consumed by the plants that made the fuels in the first place.
I think second-generation biofuels, such as switchgrass, if grown on wasteland, which is unsuitable for growing food and which does not have high-value ecosystems on it, such as tropical rainforests, which provide a wealth of ecosystem services, genetic reservoirs, and which are necessary for global climate regulation, could play a part in the future mix of energy resources we will have to exploit to meet our energy needs. Some researchers have found that the carbon savings of biofuels are not all that they are purported to be. When you include in your calculations of carbon emissions all the carbon dioxide emitted in the process of growing, harvesting, processing, transporting all that biomass for its energy, i.e. the net carbon savings, and hence biofuels' ability to mitigate global warming, turn out to be much smaller.
In the future, it is predicted that a combination of sources will solve climate impacts.
The reason people are so interested in biofuels is because you need liquid transportation fuels, right? Which technologies are to do that is going to depend on a lot of factors. And that may end up being somewhat regional, right? So depending on what kind of materials a certain area has that is rich in, They may need different technologies to do that. And because there's a big issue of transporting these materials to where the plant is that makes the fuels, a circumference of 50 to 100 miles is as far as you can transport materials to make biofuels. And so that means you may have a lot more like local, smaller plants that make these things instead of ginormous refineries that make these. Smaller biorefineries, if you want to call them that, will be different depending on what part of the country they're in. So if they're in the Northeast, they might use wood products. If they're in the Midwest, they might use corn products and things like that.
We are looking, for example, the impact of different kinds of resource abundance in municipalities, and that is in Brazil. So you have some municipalities that are rich in area that produce soybean, and others that are rich in areas that have found oil. And we test different theories in political economy about the impact of how the nature of the commodity and might impact the kind of policy that you get locally. So basically, we want to see if resource abundance that goes to individuals have different consequences, political consequences in terms of investments in infrastructure, in re-election rates of politicians, and investments in health, education, and all that, rather than in a case where only the municipal government becomes rich because it receives money from oil production. In this future that I'm talking about, energy diversification, you have a role for many different players, including universities and scientists. The more scientists develop cost-effective ways of producing renewable energy, the more you will see them being adopted, because you don't have to ask voters to not use money that could be like to other priorities.
In conclusion, the benefits of biofuels as more efforts are directed towards the research sector of biofuel development for global and regional production outweigh the costs society currently perceives. It is true that biofuels such as ethanol currently demand land space and are not as energy dense as they will be with further research. However, the new research and industry possibilities in second and third generation biofuels will alleviate the stress on food supply and lessen land usage. Biofuels do have a carbon footprint because of transportation costs for biomass and feedstock. However, overall they are relatively carbon neutral. Plants take in carbon while undergoing the process of photosynthesis before they are used as biomass in biofuel production. Additionally, in the future, the use of biofuels as a transportation fuel will depend on region. Considering that the future of energy for our globe will consist of a combination of various alternative sources depending on the resources available in the region, this development in the research sector will be essential to the transition away from fossil fuels. Government subsidies and investments from people willing to take risks will be integral to this transition as well. Biofuels will be a fundamental part of our progressive transition away from fossil fuels and into a more sustainable future for our growing population.